Welcome back, my friends. We're going to go over the notes for 7.5, solving equations that involve rational expressions. And so the textbook homework is there. I hope that you're trying some homework. It is really valuable in math. People tell me I don't get math, and usually I look and they don't do their homework. And it really does take struggle to learn math, and so I kind of think that that's partly why, so I mean STEM, you need all of the math, you need to know the math, but you also need to be able to think. And I think that math builds that thinking. So strategy for solving an equation involving a fraction. And so we've already kind of learned a strategy for solving when it involves a fraction. The first step is to clear the fraction, get rid of it. Then you can solve it like you normally do. And so that's the strategy. And so how you clear the fraction is you first find the common denominator. Then you multiply every term both sides of equals by the common denominator. The reason that's okay is because we had that property, the multiplication property, and they told us that if you have something, A equals B, I'm going to say, and then you multiply both sides by any value, but in this case the lowest common denominator, they would be equivalent equations, meaning they would have the same solution set. And so when you multiply by the lowest common denominator, and then if A had been a binomial, you would need to distribute. Or if it was a trinomial, you'd need to distribute to all, because when you multiply by something, there's the distributive property. So if A is a monomial, then no problem. But if it's a binomial or a trinomial, you need to distribute. Same with B. And then remember that you're here to get rid of the fractions, and so you want to make sure that you do the reducing, the canceling out first, and then the multiplying second. And then solve normally to us means, well, what is it? And so, and we'll be going through that as we go. If it's degree 1, then we learn how to solve in chapter 1, yeah, it was chapter 1, we learned how to solve linear equation. And we said you distribute, you combine like terms on the left side and the right side, you add or subtract, you get the variable on one side and the numbers on the other. And we're saying you got to get them separated here. And then you use multiplication and division to isolate the variable. If it's quadratic or higher, degree 2 or higher, and I think your book pretty much focuses on degree 2, then what you got to do is get 0 on one side, factor it, set the pieces equal to 0, and solve. And then here is something that I said to you guys, check. It's a good idea to check. Well, on these, it's not just a good idea to check, it's necessity to check. Because remember that the denominator should not be 0. And when you clear the denominator here, and then you solve it normally, you might get what's called an extraneous solution. Something that solves this here, but didn't solve the original because the denominator was 0. So you want to make sure that you go back and check and make sure that the denominator is not 0. So this is the thoughts on how to solve these. So I would look at this problem, it's asking me to solve, it has an equals in it, and I would be saying to myself, oh, it's fractions, ooh, fractions, fractions. So that's what I would be thinking, oh, fractions. And when you have fractions and you're trying to solve, I say to myself, clear them, get rid of them, right? So you have to find the common denominator. And just a little bit ago in 7.4, we actually had found the common denominator between x and x squared. Do you guys remember what it was? And so I can hear some of you mumbling. Others are looking at their cell phone. And so I'm just joking. Anyway, so the common denominator, right, we built it. We had x, and x squared is equal to x times x. So this says you got to have an x for the lowest common denominator. This one says you got to have 2 x's. Well, I don't have 2 x's, so make another one. Got to have 2 x's. And now it meets both conditions. Got to have 1 x, yes. Got to have 2 x's, yes. And so hot diggity dog, that's the lowest common denominator. Now you could write it as x squared. xx and x squared are exactly the same. And so your choice on that. And then what we're going to do is we're going to multiply both sides of equals by that. And I'm usually too lazy to write this, but I always write it the first time. Oh, I'm going to have to scoot that over a little bit because I didn't leave myself enough room to write it in my talk of how lazy I am. So right here, I'm going to multiply this whole side, which is a binomial, by the common denominator, x squared. And I'm going to multiply this whole side, which is a monomial, by the common denominator, x squared. And so that's that property that we learned all the way back in chapter 1, that what you do to one side when you multiply, you got to do to both sides. But we just haven't had with a binomial before. And so now I'm going to be distributing this, x squared times 2, so x squared times 2, distributing this, and plus x squared times 5 over x equals, on the other side, I'll write it again just because I'm here, and then I'm going to do my simplifying. And so you simplify these pieces, and this is the line I usually write first. I wrote that so that you know, hey, that's the property. And then this is the line I usually start off with. So when I multiply those together, there's no reducing to do, so it's just 2x squared. When I multiply these together, this is x squared over 1, and remember what that is equal to. I'm going to write that over here, that thought. This is x squared, right, is x times x over 1 times 5 over x. And I'm here to reduce, and that x reduces with either one of those x's, it doesn't matter which one, and leaves me an x and a 5 and 1 in the denominator is all I have, and so that's just 5x. So this is plus 5x. And then over here, over 1, right, and I don't have to do that one on its side because it's like perfect, right? X squared with x squared is 3. And now I'm looking at this problem that I have here, and it has the same solutions as this one, other than you should not have anything that makes the denominator of this 0. And so otherwise it would have the same solutions. And so if we get that, if we encounter that, then we'll deal with that. And so I'm on this thing right here, I'm thinking, oh, it's quadratic. Quadratic means, right, degree 2. It's degree 2. And so here's the degree 2, right, x to the second. And what that means, what you do when it's degree 2, is that means to get, there's steps, right? Get 0 on one side. So I'm going to get 0 on one side. Step 2 is I'm going to factor it. And then I'm going to set the pieces, which is different than Mises, equal to 0 and solve. Oh, just a second. Doug, it's for you.
Hello?
Sorry, that was an important phone call from, not for me, but for my husband, and he was not here to get it. So minus 3. I don't know how to back up or edit that out. I would do it if I could. So that's not like terms with the 5x. So I'm getting 0 on one side, so I'm taking away 3. So my plan is to get 0 over here. And those are not like terms, but I'm getting it in order, so that's okay. And then, so we got 0 on one side. Now we're going to factor it. So we're going to whip out our factoring. And so, you don't want to get in my video, babe. You didn't, don't worry. And so he could get in the video because he's not as shy as I am, and I'm not getting in the video myself. I'm trying to keep my fingers out of it. I'm surprised I haven't got gloves out. And so here it's got to subtract to give 5, and I can see that 3 times 2 I can make 6, and so that will be good. So x and 2x. And I know I'm going to have to put the 3 and the 1 here, and I told you guys I was planning on making 3 times 2 to make 6, and then x times 1x to make 1, and then 6 take away 1 is the 5, right? And I want it to be positive, so I'm going to have to put a positive here to make the 6 positive, and the negative here to make to take away the 1. So that equals 0. Then what you do is you set your pieces to 0. So that's x plus 3 equals 0, and 2x minus 1 equals 0. And then you solve those. So I'm going to have to take away 3. This is now linear. Degree 1, right? And what you do to solve something that's linear, degree 1, is you get them separated, right? That's the basic thing. And because I don't have any distributive property or any like terms to combine, I got to get them separated. So this is degree 1. That's x to the first. That's x to the first, right? And so taking away 3, I get x equals negative 3. And I'm going to add 1. So this is 2 steps. 2x equals 1, and divide by 2. X equals half. And so my answers are x equals negative 3 and half. And I know I've written all over this paper like a crazy person, and I'm looking for a piece of scratch paper because I'd like to check my answer, and because I wrote all in, how I am, I'm going to have to go on scratch paper to show you that, hey, yeah, it works, and what we're looking for. So I'm ripping out a piece of paper here so that I can check my answer. When you check your answer, you need to check back in the original. So you go back to the original, which was 2 plus 5 over x equals 3 over x squared. And you only check these things one at a time. So I can either check negative 3 first or half first. It doesn't matter. So I'm going to start off checking x equals negative 3. And where I see x, I'm going to put in negative 3. So this is going to look like 2 plus 5 over, and then there's where my x is, equals 3 over negative 3 squared, right? And I'm going to put in negative 3 in those spots. And then your choice on if you do this with your head or if you do this with your calculator or your head, whichever one you want. But I'm going to verify that the left and the right are equal to one another. I see that the denominators are not 0. This denominator is negative 3, and that denominator is actually 9. And so the denominators are not 0. And so that means that if it doesn't equal, I've made a mistake. And so it's not an extraneous solution. It's looking good. So I'm getting my calculator up here, and I'm going to be adding 2 and then plus, and then I want to make the fraction, so the fraction key, and 5, and then I want to go downstairs, and you can put parentheses around the negative 3 if you're just a person that wants to make sure that you make it look exactly the same. You certainly can. And so now I made it look exactly the same as that side. And so this is equal to 1/3. You could have done it with your head too. And then this side over here, you could do this with your calculator or your head. And so if I do it with my head, that's 3 divided by 9, which is 1/3, right? So if I do it with my calculator, I have to put my fraction key, 3, go downstairs, put my parentheses, negative 3 in my parenthesis, and square it, and then I get 1/3. You can always pause the video. So like if you are wanting to check this, but you realize your calculator was someplace else or you went too fast, you could pause, right? So make sure that you're doing a little pausing too. So that one worked. I want to verify also that x equals, and was it positive half? It was positive half, also works. So we're going to have 2 plus 5 over equals 3 and then over squared. And we're going to be plugging in half. And so I want to show you how to put that in your calculator. So 2 plus, and then fraction, and in the numerator 5. And we go in the denominator, and I'm going to put it in just exactly like we see it, parentheses, and then fraction, and in the numerator of the fraction 1, and go downstairs, and the denominator of the fraction 2, I want to go out to the side to end the parenthesis, And now it looks exactly like it looked on the screen. And this is equal to 12. And so I want to verify that this also equals 12. If it doesn't equal 12, then I have made a mistake somewhere. And so we'll try it. So fraction 3, go downstairs, parentheses, and then I want the fraction half. So fraction 1 over 2. Go out to the side to end my parenthesis and square it. And you could use this is the raise to anything you want button, and that's the raise to the second button. I can do this button, and then I have to type in a 2. And that's helpful when I wanted a 3, right? And so it worked. So both of them are good answers, right? So I can go on to the next problem. So we did a lovely job on that. Okay, so that was problem 14. This is problem 15. Oh my gosh, problem 44 down there. Oh, do only one. Oh my goodness. What do I do about do only one? Okay, so what was I thinking, right? I was probably thinking that I'd let you guys choose, knowing me, so kind. Anyway, laughing, rolling my eyes to myself. Okay, so I'm here and I'm going to try to do this problem. It looks like there's a little bit of a typo that got to be a capital X, but I'm sure that they're all lowercase x and there's not 2 x's running around. And so what we're going to do is we want to clear the fraction. So in order to clear the fraction, you have to factor all of the pieces so that you have, so x, all of the denominators. X plus 5 is factored, and you can put parentheses around it to tell yourself did it. X plus 4 is factored, did it. X squared plus 9x plus 20.
Okay. Doesn't have to be right now. Let's give them a chance to weigh in.
Is x plus 5 times x plus 4. Right? And so hot diggity dog. So what we're going to do is we're going to have here 2 over x plus 5. I'm going to leave a lot of room. And 3 over x plus 4 equals 2x over x plus 4, x plus 5, x plus 4. And the common denominator, right, says got to have an x plus 5, so we put it. Got to have an x plus 5, got to have an x plus 4, so we put it. Sorry, something's going on in my family and it's distracting me. I'm thinking, what's going on out there? And then here, this trinomial, remember it factored to x plus 5, x plus 4, and it says got to have an x plus 5 and got to have an x plus 4, and we have them, got them. And so, and when I wrote this equation again, so here's the first term, boink, here's the second term, boink, here's the third term, but notice I wrote it in factor form. And now I'm going to multiply every single piece here, both sides of equals, by, I'm going to scoot that over a little bit, by the common denominator. So I'm going to multiply by x plus 5, x plus 4 over 1. And then times here, x plus 5 times x plus 4 over 1. And then times here, I'm going to scoot that equals over because I didn't give myself the right room. So multiplying, notice 3 terms, all 3 terms, x plus 5, x plus 4, over 1. And I'm here to reduce. And what reduces from here is the x plus 5. There's one in the top and there's one in the bottom. And that leaves 2 times x plus 4. And I'm going to need to distribute that, and if you wanted to go ahead and distribute that before writing it down, you could. X plus 4 and x plus 4 leaves 3 times x plus 5. I write the monomial first because that's what I'm used to. And then x plus 5 and x plus 5 and x plus 4 and x plus 4, leaving just 2x on that side. And so I was on, oh, it's got fractions. And the thought is, clear them, right? And so we just cleared them. And now my thought is, as I look at it, oh, it looks like it's linear, right? Because when I multiply 2 times x, I don't get x squared. So in fact, let me multiply this together to prove to you that it's just linear. And so how you solve a linear equation is you use the distributive property, which I'm using right now. Then you collect like terms. So 2x and 3x are like terms and make 5x. And 8 and 15 are like terms. And 15, 16, 17, 18, 19, 20, 21, 22, 23. So plus 23 equals 2x. Then you get the variable on one side and the numbers on the other, and there's a variety of ways of doing it. So now I'm on degree 1, linear, right? That's what I'm on solving now, and that's get them separated. And so I'm going to take away 5x from both sides. So I get 23 equals negative 3x, and I'm going to divide by negative 3. So I get, when the dust clears here, x equals negative 23 over 3. That doesn't reduce. And I notice I did not leave myself room to check. And so I've got my scratch piece of paper for my checking. So here I am going to check that. I only have one answer. And so when I go to check, you always check in the original. So this is going to be 2 over, and remember our original was x plus 5. So I'm going to have here plus 5. And plus 3 over plus 4 equals 2x over the x squared plus 9x plus 20. And I'm going to be putting in to all of those spots negative 23 over 3. Okay? And right here too, negative 23 over 3. And 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 it's like, that's a lot of putting in negative 23 over 3. And so I'm going to show you something that you can do to put it in your calculator that I think is helpful. So when I go to put this in my calculator, getting my calculator here, I can put in my calculator, turn it on here, and I'm going to put in negative 23 over 3. And I'm going to hit equals. And so I hit the equal button down here. And that put it down here. So now that's my last answer. And so when I go here to put this in, I can put in my fraction and 2, and then I can go downstairs and I can put parentheses if you like, or you don't have to use the parenthesis, and hit the answer key, because what was the answer? Negative 23 over 3 plus 5. So it just saves me from typing that. And then out to the side, plus, and then fraction 3, and then downstairs, the answer, and the answer key is down there at the bottom, and then plus 4. And so remember what it put in for the answer is negative 23 over 3, our last answer. And so that gives us negative 69 over 44. Negative 69 over 44. Now, if the other side is also equal to negative 69 over 44, then we know that we haven't made any mistakes and we have a good answer. If it's not equal to negative 69 over 44, then we know there's been a mistake. If you just go and use the answer right now, the answer that it'll be putting in is 69 over 44, negative 69 over 44, but I want to put this in. So I have to do that trick again. I have to clear it and put in negative 23 over 3, right? I put it in a little bit differently that time. I put it in as a divide, but you notice when I hit equals, it's exactly what I want. And so now I can put it in as the answer. So 2 times the answer, go downstairs, and the answer squared, and plus 9 times the answer. You don't have to put the parentheses around the answer there, I don't think. And so I don't know why I'm going to put them in, because just this is what it looks like over there. And so I'm going to get the same, negative 69 over 44. And I'm like, okay, yay, that means it was a good answer. Also, you notice it didn't make any of the denominators of the original 0. This was not 0, this was not 0, and this was not 0. And I do know that I have one where it does make a 0. I'm going to end this video here for part 1, and then come back in part 2 and do 44. I don't know if I'll do all of them or if I'll only do one of them. Knowing me, I'll do all of them. And then 56, because you know how much I love math. And then there's bonus problems there on the back, but I think I'll do those bonus problems in a whole different video. It's getting a lot today. So I'll end that here. Hello, welcome back. We're still working on, which section was it? It was the solving section, right? And it was 7.5. And we had this problem 44, and I had said, do only one. And so, and I said that I probably wouldn't be able to resist doing all of them because that's how I am. I'm going to start with C because it's the easiest one. And so it says, C says f at x equals negative g at x. So f at x is 4 over x plus 2, using our function notation from chapter 6. And then g at x is 4 over x minus 2, but remember it has negative here, so it's negative of that fraction 4 over x minus 2. Then I want to solve this. That's what they're asking me to do, is find x, so solve for x. And how I would solve that for x is first to get rid of the fraction. And how you're going to get rid of the fraction is by finding the common denominator, which is by factoring the denominators. So this is x plus 2, doesn't factor. X minus 2 doesn't factor. So the lowest common denominator is x plus 2, x minus 2. My computer is going crazy because my calculus students have something due here in 3 minutes, and so it's now bling bling blinging. And so I'm going to multiply this fraction and that fraction by it. So, and it doesn't matter which side of that I write it on the left or on the right. So I'm going to multiply by x plus 2, x minus 2, and the same over here, times x plus 2, x minus 2. And I'm here, this is over 1, I'm here to cancel. This is over 1, I'm here to cancel. And so the x plus 2 reduces with the x plus 2 and leaves, and I would write it as the monomial 4 times x minus 2 equals, and then the x minus 2 reduces with the x minus 2 and leaves the minus 4 with the x plus 2. And then you would solve that normally. And so when you solve this, you're going to get 4x minus 8 equals, and then negative 4x minus 8. And if I'm solving that, I would, it was fraction, right? And so I cleared the fraction. And now I'm on, oh, it's linear. And so you would add 4x to both sides and add 8 to both sides. So I get 8x equals 0. And I'm going to divide and divide by 8 to solve for x. And I get x equals 0 divided by 8 is 0. And I would want to check my answer. So my original equation was 4 over x plus 2 equals negative 4 over x minus 2. So if you put in 0 for those x's, you're going to get 0 plus 2 equals negative 4 over 0 minus 2. And I want to check, does the left side equal the right side? So this is 4 over 2, which is 2, and of course you could use your calculator. And this is negative 4 over negative 2, which is also 2. And so we solved it. The answer is 0. And so that was 44 part C. We'll give a try here also, can't help myself, to 44 part A. So f at x minus g at x equals negative 4/3. So what we're going to be putting in for f at x is 4 over x plus 2 minus, and what we're going to be putting in for g of x is 4 over x minus 2 equals negative 4/3. And then I would want to get a common denominator, and this doesn't factor, and 3 is doesn't factor either. I wouldn't probably put I put the parentheses around the binomials to remind me, hey, that's one piece. So the lowest common denominator, I always like to name the monomials first, is a 3, and an x plus 2, and an x minus 2. And that's what I'm going to be multiplying all 3 of these pieces by. I'm going to go and multiply by that lowest common denominator, and the x plus 2 is going to drop. By the common denominator, and the x minus 2 is going to drop. By the lowest common denominator, and the 3 is going to drop. So that's going to be my plan and how I'm going to go here. So, and it doesn't matter which side of the that you write it on. So I'm going to give myself some space here. And so when I multiply times, it doesn't matter if I write this on the left or the right, 3 times x plus 2, x minus 2 over 1, and then minus and 4 over x minus 2, and then I'm going to multiply that by 3 times x plus 2, x minus 2, and then equals negative 4 over 3, and then times every single one of them, 3 times, because of the distributive property. And I'm here to cancel, right? And this is over 1. This is over 1. And the x plus 2 cancels with the x plus 2. And what that leaves is this stuff left over that I need to multiply together. And I can multiply the 4 and the 3 together really good with my head. That's 12. And then times x minus 2. And then here the x minus 2 cancels with the x minus 2. And I can multiply together really good the 4 and the 3 together. That's 12. And remember, I have minus. Minus 12. And then x plus 2. I have that x plus 2 as well, right? And then on the other side over there, the 3 cancels. And so that gives me a monomial, minus 4. And then I have this binomial times that binomial that didn't reduce or cancel. And now, this is my new thing to solve. So I was up here saying, oh, there's fractions. Got to clear the fractions, find the common denominator. And now I'm looking at this and thinking, is that linear or is that quadratic? I can see it has no fractions. And so, but is it linear or is it quadratic? And so right here, if I was to multiply that back together, that'd only be 12x minus 24, and etc. So that's not x to the second. But look right here, x times x is x to the second. So I know it's going to be quadratic. So I'm going to multiply this together so I can get 0 on one side. So even if it was linear, I'd be saying to you, I'm going to multiply this together. So we're going to have here 12x minus 24 minus 12x minus 24 equals, and then I can't multiply 3 things together at one time, and so I'm going to choose to multiply these together and then distribute the negative 4. So I'm going to have minus 4, and I'm going to multiply this together. Now I know when I multiply this together that when I FOIL it, that the outer and the inner are going to make 0. So I'm just going to be lazy and multiply the first and the last. So this is going to give me x squared, and this is going to give me minus 4x, And so when I multiply this together, I'm going to have negative 4x squared plus 16. And on the other side, I might as well combine the like terms and put it down here. So I have 12x minus 12x is 0, and negative 24 and negative 24 is negative 48. And so now I'm going to try to solve this equation here, and it's degree 2. When you have degree 2, you want to get 0 on one side. And I like, because I'm going to have to factor, to have my lead term to be positive. So there's my leader right there, and my leader is negative. So I'm going to make this side be the 0 side. So I'm going to add 4x squared to both sides, so plus 4x squared. And I'm going to take away 16, right? So that gets 0. And take away 16, take away 16, so that this side becomes 0. And this side is 48 and 16. So I'm going to add that with my calculator. They're both negative, so I really am adding, and it's going to be a negative 64. Okay, so this is 4x squared minus 64. After you get 0 on one side with your leader being positive, like it is, then what you want to do is you want to factor. So you want to whip out your F word, factor. And when you have a binomial, you start with the greatest common factor. And the greatest common factor here is 4. So I'm going to pull out a 4. Let's see, 4 goes in there 16 times. Equals 0. And then that's a difference of squares. So I factor it like my friend, that's my best friend, the difference of squares. And so now what I want to do is I want to set the pieces equal to 0 and solve. So it's silly to set 4 to equal 0 because 4 never equals 0. So really that gets ignored. But here's where things could change because it's a variable. X plus 4 could equal 0. That's when we're at negative 4, right? X is negative 4 is our answer. So we had degree 2 and this is degree 1. And you solve it normally, which is get them separated. And then we have this other solution, which is also degree 1, linear, and all you have to do is get it separated. All you have to do is add 4. So we have our answers 4 and negative 4. And you have to check, you have to make sure that it works back in the original equation. And so it's a must check. Will I run out of room? Well, I could just start on a different piece of paper already and not have the stress of running out of room. And you have to check in the original. So that's 4 over the blank plus 2 minus 4 over the blank minus 2 equals negative 4/3. And I'm going to check these one at a time. I'm going to be putting in here negative 4. So I'm going to put that in my calculator and see, does that equal negative 4/3? So the fraction 4 downstairs, parentheses if you like. Parentheses are not necessary, but if you're like, I'm writing it exactly the way I have it, you can. Definitely, your calculator knows. I don't think it laughs at you or anything like that when you put in parentheses that weren't necessary. It only laughs at you when you don't put in parentheses that were necessary. And so when I do that, I get negative 4 over 3. Using my calculator equals negative 4 over 3. And so that means that x equals negative 4 was a good solution. Now I want to go check 4. So the same way, I'm going to check 4. So when I put in 4 here, the good news is I already have that on my screen. And I did put the parentheses, so that alerts me to where I had the substitution. And so I just hit the backup key and I'm just backing up and I'm going to delete that negative. So I got right there. And sometimes I make a mistake and I delete the thing I didn't want to delete, but I've kind of learned that you have to be right after it and you hit delete and it backs up over it. And so now I've got exactly what I was wanting to have here, right? Putting in the 4 and into that equation, and I'm hoping that's going to equal negative 4/3, and it does. If it doesn't equal negative 4/3, then I've made a mistake. If it equals math error, then that means that you had 0 in your denominator and it's an extraneous solution, which it didn't. You always have to check these. And so if it equals something other than negative 4/3, I made a mistake. If it equals math error, then that means it was an extraneous solution that really made the original equation's denominator equal 0. Okay, woo, those are long, right? I mean, that seems so, would you like to do all 3? Do only one. And I think I let my class last semester choose. And here I am boring you with all of them. But maybe you take it as an example. It certainly has practice of everything we've done so far in the class, and so that's the good news or the bad news or whatever have you, is practicing, right? So g of x is equal to 4 over x minus 2. So I'm replacing in, this is my main fraction bar, right? And I'm going to go put in what f of x is, which was 4 over x plus 2 equals negative 7. And this is a complex fraction, and it's it's not simplified. So I think what I would do is start off by ignoring the negative 7 over there and just simplify this and then solve it. I mean, that's a way of going, certainly. And so that's going to be my plan. And because this is one fraction over one fraction, what I'm going to think here on simplifying that side is that this is 4 over x minus 2, and then divided by 4 over x plus 2. And then I'm going to turn that into a multiply. People can do that in one step and flip it here. And I'm just working on that side. So I'm just working on this side. So this really still equals negative 7. And you notice the 4's drop out. So we're left with x plus 2 over x minus 2 equals negative 7, right? So this was just me working that side to make it look better. You have to admit that this looks bad compared to that, compared to what I got now. And now I want to clear the fraction, because I notice, oh, fraction, I got to solve it. And how you clear the fraction is you multiply by the denominator, or the common denominator. I only have one denominator, so I multiply by x minus 2. So I'm going to multiply the lowest common denominator. I only have one denominator, is x minus 2. And I'm going to multiply by it right here. And when the dust clears, you get x plus 2 equals, and then you distribute, negative 7x plus 14. And then now I'm all, oh, it's not fractions anymore. I got rid of the fractions. Yay. Now it's degree 1. And degree 1, linear, you got to get them separated. So I'm going to get the x's on one side and the non-x's on the other. So I'm thinking about adding 7x and taking away 2. And when the dust clears here, 1x plus 7x is 8x. And equals, I was thinking 16, because I was thinking, oh, it'll be a nice answer. But I think it's 12. And going to be a fraction as our answer, 12 over 8, which reduces by 4 to 3 over 2, right? Still a nice answer. There's nothing wrong with 3 over 2. 3 over 2 is quite beautiful, in fact. And so now I want to check my answer and make sure that my answer is right. And you should check in the original. So that's going to be a trick, but it'll give us some practice on our calculator. So this is, the original was 4 over the blank minus 2, big fraction, 4 over plus 2. And we're going to be putting in 3 over 2. And I think I'll employ that answer key. Remember how I used that answer in the last video? So I put in my calculator 3 over 2, 3 divided by 2. There it is, 3 over 2, and now it's my answer. And now what I'm going to do is I'm going to put in a fraction, And then I want a fraction in the numerator of that fraction. So this numerator, that fraction bar is that fraction bar. And so I want to get a fraction up there in the numerator of a fraction. So I'm going to put it there. So 4, and then I'm going to go downstairs and I'm going to hit the answer and I'm going to subtract 2. Then I want to go down here. Oh, I was there. There I am. So my cursor is now in the denominator. And in the denominator, I want a fraction. So I'm going to hit the fraction key. And I want 4. And then I'm going to go downstairs. And I want to put in the answer plus 2. And I'm thinking that should be equal to -7. And if it's not, I've made a mistake. And so since it is, I'm like, hot diggity dog, right? So this is -7 when I plug in x equals 3/2. Remember, that's what I put in for my answer. And so that means that the answer for the problem is x equals 3/2. And we did a lovely job on that one. And so I know what you're thinking. Oh, wow. Oh, wow. That took you 20 minutes to do those 3 problems, and it did. So they're long, I admit, and they take all kinds of math to do. I have one more problem here on the notes that go with that section for solving. And they throw in, hey, draw this graph is what they throw in. And it's something we haven't graphed before, and they're just kind of seeing how we'll go. And so do you guys agree with me that if I start picking points, because that's what I usually do when I'm graphing, is pick a few points, and I don't know what this is going to look like. This is something I've never graphed before, right? So my favorite point is 0. And remember that f at x is a fancy way of saying y. So this is saying y equals 1/x plus 3. And so if I put in 0, then my y will equal 1/, so we're plugging in, right? 0. So that would be 1/3. And if I plug in 1, then y will equal 1/1 plus 3, which is 1/4. And if I put in 2, I'll get 1/5. Do you guys agree? And if I put in 3, I'll get 1/6. And if I put in 4, I'll get 1/7. And I hope that you're thinking, sitting there thinking to yourself, I don't even know if you can plot all of those. And so I'm gonna, but I'll give a try to seeing how that goes, right? So you certainly might be correct. So like, for example, if I plot the first one, so up 0, up 1/3, that's hardly up at all. And then up over 1, up 1/4, that's hardly up at all. And it's not at quite as much as 1/3. And then it's not quite, 1/5 is not quite as much as 1. And so 1/4 was, and then 3. So I can kind of see that it's getting closer to the x-axis as I go. Ooh, I almost had a symbol going. And so I can kind of see that I've got this going here, right? At least. And you can imagine that if I kept going, am I ever going to get to a point that when I pick a value like 9, am I going to get 0 out of that, or am I going to get a negative out of that? I might ask myself that. And I'm not, right? When I put 9 in, I'm going to get 1/9 plus 3, and 9 plus 3 is 12. I'm going to get 1/12. And that's so close to the axis that I can't draw it, but it's not getting to 0. And even if I choose 100, I'm going to get 1/103. Which is not 0 and it's not negative. So that's not going to happen, right? This was 1/12. And so it's going to just kind of continue going on in this fashion, getting closer and closer to that axis. And so I'll just kind of leave it out there trailing off. What typically happens is that people will put a dashed line to show that it's not going to cross through that axis. Okay. Now I might be curious, well, what happens at -1? So let's see what happens at -1. So if I put that into my equation, 1 over -1 plus 3. Now -1 plus 3 is 2, so that's half. So I'm going to plot that. So 1/2. Now half is a little bigger, a little higher than 1/3 was, right there at half. And you might be curious, well, what's going to happen if you pick -2, right? Because I'm kind of seeing what happens here. And so if I do, I get 1 down there, and 1 over 1 is 1. So that is going to be -2, 1. And what if I pick -3? Well, that's 1 over 0, so that's undefined. And so that's not really something that's in the domain. Remember, they were asking us about domain. That's not something I'm allowed to choose. And so what they typically do is they put a dotted line there to show that you're not going to reach that value. And that dotted line is hard to see, I know. And my pens are weak, and my body is weak because, boy, this has become a lot today for me. And so if you think it's a lot for you, I agree. And the good news for you is that you can kind of break it up a little. And I'm feeling like I have to go straight through because I have so much calculus stuff to do as well. Okay, so I might be then curious, well, what happens between 2 and between -2 and -3? So I try -2.5 just to see. And now I might be interested in getting my calculator out. If you were already interested in having your calculator, you certainly could have that. So I want to make sure it's on, get a fraction, 1, and then I'm going to put the parentheses that I'm going to be filling in with -2.5. And then I'm going to add 3. And I get 2. So -2.5, I get 2. I'm going to plot it. And then what if I got closer? Like -2.9. So I'm going to go fill in here. And I get 10. So -2.9, that's 7, 8, 9, 10, ... right? And so you can kind of see that it looks like on this side that my graph goes like this. Almost straight up there. Not quite straight up, but it looks almost straight up there. Okay, so we have a lovely drawing of there. This is how a rational expression would look. And now I want to look at, well, the other side. So what if, so we said that it wasn't okay to pick -3, but how about -4? And now that I've got this on my calculator, I think I'll just start putting it in the calculator and using it to do my value. So I get -1. So -4, -1. And I'm going to choose -5. And I get -0.5. So here's -5, -1/2. And I'm going to choose -6. And I get -1/3. So that's even closer. And then you can kind of imagine that same thing happening over here, that I'm going to get closer and closer to the x-axis, but I'm not going to cross the x-axis. It's never going to be 0 as I plot in those points. It's never going to equal, the y value is never going to be 0. If you put in a value here, right, you're never going to get 0. And so what if I got closer to -3? And so things like -3.5. So if I put that in, 3.5, that's at -2. So 3.5 is here, it's at -2. And if I picked -3.1, I get -10 here. And so it kind of does that same thing. So I would really encourage you to go and look at more of the graphing that, that they have in the textbook. And so there is the end of this video here. And so I'm not going to do these bonus problems for today because I just think that today's already overwhelming. And so make sure now you give yourself a rest. The governor says that it's okay to have a little walk as long as you're not walking near other people, I guess. I don't know. You decide on that, but go in your backyard or go somewhere. I get a little sunshine. I was so depressed, and I know that it's a little bit cloudy out there, but it did help. Okay, talk to you later. Bye-bye.